student, I Abhishek Misal welcome you to on the lecture on arithmetical logic unit. In this lecture we cover the following points. First, introduction of arithmetical logical units. Second, implementation of an arithmetical logic unit. The next is ALU slice. The next point is subtraction of the ALU unit, and the last is addition and subtraction with overflow detection in ALU units. Now first I introduce you to about the arithmetical logic unit. The arithmetic logic unit is the core component of a central processing unit that is called CPU, responsible for performing arithmetical and logical operation. Its primary function to involve executing mathematical, computational and logical comparison necessary for processing instruction with a computer system. At its essence, the ALU is the computational brain of CPU undertaking the fundamental task required for processing data. It operates on binary data, manipulating bits according to the instruction provided by CPU, comparing multiple logic gates such as AND, OR, NOT gate and various arithmetic circuits. The ALU execute a diverse range of operations to perform complex calculation and decision making process. Arithmetical operations are fundamental to ALU's function. It can perform basic mathematical tasks like addition, subtraction, multiplication and division. These operations involve binary addition and subtraction with multiplication and division achieved through a series of iterative addition and shifting operations. Moreover, the ALU handles logical operation crucial for decision making and control flow within a computer system. Logical operation includes AND, OR, XOR and NOT, allowing the ALU to compare value, test condition and execute branching instruction. Based on these comparisons, the ALU architectures involve input register that store data temporarily, the arithmetic circuit responsible for computation, control signal directing the operation to be performed, and output register that hold the result when an instruction is fetched from the memory. The ALU decodes it to determine the necessary operation and execute it accordingly. ALU can operate on various data types such as integer, floating point, number and sometimes even characteristic or string. This flexibility is achieved by employing different circuitry and algorithm tailored for specific data type. Parallelism and pipelining technique are often implemented with ALU to improve processing speed by executing multiple operations simultaneously or overlapping stage of instruction execution. These methods optimize throughput and reduce latency. Basically, the arithmetical logic unit is a fundamental component of a computer central processing unit responsible for performing arithmetic and logical operation on binary data. Here we will discuss the detailed various operations typically executed by an ALU. The first operation is addition. The ALU performs binary addition, the most fundamental arithmetical operation. It takes two binary numbers and produces their sum utilizing basic logic gates like AND, OR and XOR gate. Subtraction. Binary subtraction is executed in the ALU by complementing the second operand and adding it to the first operand, similar to adding using 2's complement arithmetic unit. The third operation is multiplication. The ALU employs various algorithms like Boolean algorithm to perform multiplication. It's break down the multiplication operation into a sequence of addition and bit shift efficiency, producing the product of two numbers. The next is division. Division is a complex operation but that ALU execute through iterative subtraction and comparison process. Algorithms like restoring or non-restoring division are used to find the quotient and remainder. Logical and or XOR NOT operations are also performed by the ALU. These logical operations manipulates bit based on logical condition. The ALU perform logical and or XOR, that is exclusive or and not, that is called complement operation on binary. For example, bitwise and compare corresponding bits in two operands and produce a result with a firm one in each position where both operands have same number. Now the next is shift operation. ALU also handle shift operation where bits are moved left to right in binary number. Logical shift insert 0 from one end, while arithmetical shift retain the sign bits in the leftmost position. Now the major important operation is comparison. Comparison operation, ALU compare two values to determine their relationship such as equality, greater than, less than, etc. This is crucial for decision making and branching in program. Bitwise operation, these involve manipulating individual bit in binary data. Bitwise operation include setting bits, clearing bits, toggling bits, extracting specific bit, etc. Overflow detection. ALU often include mechanism to detect overflow, indicating when the result of an operation exceed the range that can represent by the number of bits used for storage. Data movement. ALU might also handle data movement operation, transferring data between different storage locations within the CPU or to perform memory. These operations are governed by control signal generated by the CPU instruction decoder. The ALU fetches operand from register, perform the specified operation and store the result back in register for or memory as directed by the CPU. The implementation of arithmetical logic unit. Implementation of arithmetical logic unit, that is ALU, involve designing and constructing the unit using digital logic circuit. ALU are typically built using combination of basic logic gate such as AND or NOT gate, multiplexer, adder, register and other component. Here an overview the steps involved to implement an ALU specification. Begin by defining ALU specification includes operation. Its need to support addition, subtraction, logical operation, shift, etc. The size, number of bits and any special requirement based on CPU architectures it intended for. The design based on specification. Design the ALU's architecture, determine the number and the type of logic gates need for each operation. For example, For addition, a combination of XOR and OR gates are used. The logic circuits create for each operation. For instance, a full adder circuit, it arithmetical operation, logic operation like AND, OR, XOR and NOT are implemented using their corresponding gates. Now the next is control unit. The control unit develop a control unit responsible for decoding instruction from the CPU and generating control signal to direct the ALU's operation. These control signals determine which operation the ALU perform and manage data flow. The figure show the ALU is internal structure, that is called ALU slices. In this circuit block diagram, you see that there is a AND gate, OR gate, NOT gate and also adder, and here we also include multiplexer, which is give the single output from the multiple input, and the two table also available for to better understanding. And ALU slice, also known as ALU cell or ALU slice unit, refer to a subsection or a basic building block of an arithmetic logical unit, that is called ALU. It represents a portion of the ALU responsible for performing specific arithmetical and logical operation on binary data. ALU slices are replicated, the interconnected to form a complete ALU capable of executing a wide range of operation. And ALU slice typically compare essential component necessary for basic arithmetical and logical computation. The another part is register. ALU slice often include register to temporary store operand and result. These registers hold data during the execution of operation within the slice. Logic gate. Basic logic gates such as AND, OR, XOR and NOT gates are fundamental component within the ALU slice. These gates are combined in different configuration to perform arithmetic operation like addition, subtraction, multiplication, division and logical operation. Now the multiplexer and the selectors. Multiplexer are used to select input or output within the ALU slices, especially when dealing with multiple operation or data path. Selectors help in choosing a specific operation or function based on control unit. Arithmetic circuit. An ALU slice include circuit for an arithmetic operation like addition, subtraction. These circuit may involve gates configured to perform binary addition, often using look ahead or ripple carry adder architecture. Logical circuit within the ALU slice facilitate operations like AND, OR, XOR and NOT, enabling comparison and bitwise multiplication data. Control signal. Each ALU slice receive control signal from the control unit of the CPU. These signal detect which operation the ALU slice should perform and control the flow of data and result. Now we show the block diagram of subtraction circuit. In this circuit we using XOR gates for and full adder for subtraction. The block diagram is shown below. Now the process will be discussed in next. The integer subtraction in an arithmetical logic unit is typically executed using combination of addition and 2's complement arithmetic. The ALU performs subtraction by adding the min. Another number is subtract and 2's complement of the subtrahend. The number being subtracted. Here's step process. Convert the subtrahended to 2's complement. To subtract a number b from a, the ALU first convert the number b subtrahend into its 2's complement from. This involves taking the 1's complement, that is flipping all the bits, and then adding 1's to the result. Perform addition. After obtaining the 2's complement of the subtrahended, the ALU adds this value to the minute. This addition operation is performed using the ALU adder circuit. Now discard overflow. During the addition, there is an overflow carry out of the most significant bit. It indicates that the subtraction has resulted in an overflow condition in 2's complement. Arithmetic overflow signifies that the result is beyond the represent range. Obtain the result. The final result of subtraction is the output of the addition operation performed in the ALU. If there is no overflow, the result is the correct subtraction of the two numbers. For example, consider a subtraction a minus b, where a is minute and b is subtrahended. To perform a minus b, obtain 2's complement, that is b minus b, 2's complement of b. Add a plus minus b using ALU adder circuit. The ALU utilize this adder circuit and control signal to execute their step by performing addition with the 2's complement of the subtrahended. The ALU efficiently achieve subtraction in a binary arithmetic. Now we discuss the addition or subtraction with overflow detection in ALU. An ALU with overflow detection is designed to perform addition and subtraction operation while detecting whether an overflow condition has occurred. Here how the ALU with overflow detection typically work for addition and subtraction. Addition and overflow detection. Perform addition. The ALU adds two numbers a and b using its adder circuit. It sums up the value of a and b, including any carry from the previous bit addition. Overflow detection. To detect overflow, the ALU examines the carry out bit from the most significant bit, that is MSB position, after the addition. If there is a carry out from the MSB but no carry in, it indicates overflow for unsigned number. For signed number, using 2's complement represent overflow occur when the carry in and carry out of the MSB differ. Flag generation. The ALU set an overflow flag for status bit in the control units to signal whether an overflow occur. the flag can be used the CPU or subsequent per operations to handle the overflow condition appropriately. Subtraction and overflow detection. Convert subtrahendeds into 2's complement. In preparation for subtraction, the ALU converts the subtrahended b into 2's complement from minus b. Perform addition. The ALU execute a plus in the bracket minus b, where a is the minute and minus b is the 2's complement of the subtrahended. It uses the same addition process as described for addition operation. Overflow detection. Similar to addition, the ALU check the carry out bit from the MSB after the addition. If there is a carry out from the MSB for unsigned, or if the carry in and carry out of the MSB differ from sign, it signifies overflow during subtraction. The next is flag generation. An overflow flag is set based on the overflow detection result, indicating whether the overflow occurred during the subtraction operation. The circuit diagram of the subtraction operation is shown below, where you can see that here we are using the n number of XOR gate as well as n number of full adder to perform the subtraction. Now types. There are so many types of ALU, that is depend on the bits. We are basically discuss the two common type of the ALU, that is 1-bit ALU and the second is 32-bit ALU. Now first discuss we will ALU, that is 1-bit ALU. It is a basic arithmetical logic unit. It is a basic arithmetical logic unit. It can be ALU with overflow detection, is designed to perform addition subtraction operation while detecting whether an overflow condition has occurred. Here how an ALU with overflow detection typically works for addition and subtraction. This is the block diagram where we using the AND gate, OR gate and full adder and multiplexer to perform the 1-bit arithmetical logic operation. Now design of 1-bit ALU. In design of 1-bit ALU involve several key components. Operands, inputs, A1 bits. ALU takes a 1-bit operand, usually designed as operand A and operand B, for performing operation like add, addition, subtraction and OR gate. Operation section. It includes control line that determine the operation to be performed, that is addition, subtraction and OR gate. This line specify the function to be executed by the ALU. Now the arithmetic unit. The arithmetic unit is responsible for performing arithmetic operations such as addition, subtraction. It consists of logic gates and adder designed to handle a bit number. Logic units. This part handle logical operation like AND, OR, NOT, XOR gate. It involves logical gates such as AND gates, OR gates and NOR gates to perform bitwise operation. Now the result in the register, a storage unit that holds the result of the operation performed by the ALU. This register stores a bit result along with overflow or carry out bit in case of arithmetic operation. control unit. Similarly, it coordinates the overall operation of the ALU based on operation selection input. It detects data flow between the operand, the arithmetical logic units, and the result of the register. Flag register. Some ALU generates the flags like zero flag, carry flag, overflow flags, indicating specific condition resulting from the operand, carry in addition, overflow in sign arithmetic. Multiplexer and demultiplexer. These components help in directing the flow of data and controlling inputs output to different parts of ALU based on operation being performed. Now we discuss a 32-bit ALU, that arithmetic, that is briefly. A 32-bit ALU is designed to handle the 32-bit binary number and perform arithmetical logical operation on them. It is an essential component of the CPU responsible for executing arithmetical calculation and logical operation in a computer. The design of 32-bit ALU encompasses several crucial components, that is operand inputs. The ALU takes two 32 operands, that is operand A and operand B, for perform operation like addition, subtraction, and or etc. Now the operation selection. Controls line determine the operation to be performed, addition, subtraction, logical operation, shifting. The line specifies the function to be executed in the ALU. The next is arithmetic unit. It performs arithmetic operation like addition and subtraction. It consists of a series of logic gates, carry, look ahead adder, and other components designed to handle 32 bits numbers efficiently. Now the next is result register. Similar to the a 1-bit ALU, this register stores the result of the operation performed by ALU. It stores the 32-bit result along with an carry out or overflow bit generated during arithmetic operation. Multiplexer and demultiplexer. These components assist in directing the flow of data and controlling inputs output to different part of ALU based on the operation being performed. Now we discuss the application of ALU. The arithmetical logic units are fundamental components found in processor, microcontroller, and digital system. They serve numerous applications across various fields like central processing unit. ALU are the core CPU performing arithmetical logical operation, executing instruction. They handle tasks like addition, subtraction, and or shift and comparison operation in every computational task the CPU perform. Microcontroller. Embedded system include microcontroller found in appliances, automobiles, and industry machinery. Utilize ALU for computational. This system handles specific tasks for processing the data using ALU, ensuring functions like sensor, data processing control system, and interfacing with external device. Digital processing unit, that is called DSP. ALU plays a crucial role in DSP applications such as audio and video processing. They perform mathematical operation on signal including filtering, modulation, and encoding, decoding, enabling the function like noise reduction, image processing, and comparison. Graphics processing unit, that is called GPU, in the realm of graphics and visual computing, ALU in GPU handles complex calculation for rendering, image processing, texture, playing, effect, and executing shader to create realistic visual in video games simultaneously, and graphical application. Cryptography. ALU are used in cryptographic system for encryption and decryption algorithm, hash function, and secure communication protocol. They perform securing data and ensuring privacy in digital communication. Artificial intelligence and machine learning. ALU are employees in neural network and machine learn algorithm for performing matrix operation, activation function, and other mathematical computation crucial for training and interface in AI models. Scientific computer. The high performance computing like relies on ALU for executing complex simulations, scientific computation, weather modeling, and other data intensive tasks requiring vast amount of calculation. Now, networking and communication. ALU are involved in handle data packets, routing decision, error correction, and protocol processing in networking equipment, ensuring efficient data transmission and communication across the network. These are the application of ALU. So if we understand the AND OR operation and their application is ALU, so we can develop the different electronics devices. So for this I conclude my lecture, and thank you for listening me patiently. Thank you.